everyone, I'm Professor Harrison, and welcome back to our module on regression. Today we're covering fitted values, residuals, and two properties of residuals that matter a lot more than they first appear. We're following Margot, a graduate student piecing together the story that her family buried, using regression to make sense of a box of old letters, a stack of published articles, and Victor's old account statements. Last time she fit a line to Victor's returns in the market. Today she's going to use that same line to ask a different question. Not how the fund tracks the market, but what's left over once the market is accounted for. She pulls up another page from her grandfather's fund records. Let's set the stage again because we're picking up right where we left off. Margot's been working with Victor's fund. For 5 months, she lined up the market's excess return against the fund's excess return, and the last time she fit the best line through them. That line came out to the fund's return equals 1 plus 2 times the market's return. The slope of 2 is the fund's beta, which is how hard the fund swings with the market. The intercept of 1 is the piece of the return that the market doesn't touch. Today we're going to take that line and pull two new quantities from it. The first is the fitted value. The fitted value is just what the line predicts. You take a month's market return, plug it into the line, and whatever comes out is the fitted value for that month. We write it as y hat. The hat means that it's estimated or predicted. So for the first month, the market was up 1%. If we plug in 1, 1 plus 2 times 1 is 3. So the fitted value is 3%. That's the return that the line says the fund should have in that month. The second quantity is the one that we actually care about today, the residual. We first saw it when we set up the criterion for OLS. The residual is the actual value minus the fitted value. So it's what really happened minus what the line predicted. So for that first month, the fund actually returned 5% and the line predicted 3. 5 minus 3 is 2, so the residual is positive 2. The fund did 2% better than what the line expected. Now one distinction worth nailing down before we go any further, because this trips people up. The residual is not the same thing as an error. The error is a population idea. It's the gap between the fund's return and the true underlying relationship. And we have to keep in mind that we never get to see the error because we never know what the true relationship actually is. The residual is a sample idea. It's the gap between the fund's return and the line that we actually estimated from the data that we have. The error is the thing that we wish we could measure. The residual is the thing that we can actually compute. They're very similar, but the residual is the one that ends up in our hands. Let's compute all 5. The line is 1 plus 2 times the market return. Month by month, the market was 1, 2, 3, 4, and 5. So the fitted values are 3, 5, 7, 9, and 11. The fund actually returned 5, 4, 5, 8, and 13. Subtract each fitted value from each actual return, and the residuals come out to positive 2, negative 1, negative 2, negative 1, and positive 2. Now here's where it gets interesting. These residuals have two properties that hold for every OLS regression with an intercept, and they're not accidents. They fall straight out of how OLS picks the line. The first property is that the residuals add up to 0. Look at ours. Positive 2, minus 1, minus 2, minus 1, positive 2. If we do, we get exactly 0. And this is always true. The positive misses and the negative misses end up balancing perfectly. That's actually the same fact that we used last time. The line passes through the average of the data, because it runs straight through the center, and the points above it and the points below it have to balance out. So OLS residuals always sum to 0. The second property is a little bit more complex. The residuals are what's called orthogonal to the x variable. So what exactly does this mean? Well, in concrete terms, if you multiply each residual by its x value and then add those up, you're also going to get 0. Let's check this. Residual times market return month by month. We get 2, negative 6, negative 4, and 10. Adding them up, and we get 0. So what exactly does this mean? Well, it tells us that the residuals carry no leftover linear relationship with x. If the leftovers still move with the market in some systematic way, then OLS would not have finished its job. It could have tilted the line a little bit or potentially moved the intercept in order to explain that movement. The fact that the residuals are orthogonal to x means that every bit of straight line information that x had about y has already ended up squeezed into the line. So everything that's left in the residuals is, by construction, completely unrelated to x. And if you think back to the matrix module, this is the projection idea. The fitted values are a shadow of y cast in the direction of x, and the residual is the part of y sticking straight out, at a right angle, with nothing more to give. That's why residuals are the workhorse of pretty much everything that comes after in this regression module. Once you've got the residuals, you can ask how much of the variation the line actually explained. You can also ask important questions, like whether the leftover scatter is well behaved or not. You can ask whether your standard assumptions are holding up. And all of those tools further down the line end up being built right on top of the residuals that we just computed. Margot sits back and looks at what the line has pulled apart. Victor's return splits three ways now. First, there's the piece that's related to how exposed he was to the market. The second is the steady 1% that he ended up making due to his own skill. Then finally, there's the residuals, the leftover wobble that the line couldn't account for. The most interesting thing in these early years is that 1%. That's Victor's edge, and it's clean and repeatable every month in this early sample. But she knows where this goes. The fund records run for decades, and somewhere down the line, that edge thins out and disappears. So the question she's stuck on is what happened to it? The firm's beta stays steady, so the edge had to disappear in some other way. And a real edge doesn't just evaporate on its own. So whatever ate it was something else, something outside the model, and the residuals are the one place that the model puts everything that it can't explain. In this early window, the residuals look clean, just noise with nothing hiding in them yet. But if something was working on Victor's returns that he never saw, it would be in those residuals. So Margot knows that's exactly where she needs to look. So that's the fitted values and the residuals. The fitted value is what the line predicts for each point. The residual is what's actually left over, the real value minus the fitted one. And don't confuse the residual, which we computed from our sample, with the error, which lives in the population and we'll never get to see. The residuals from an OLS regression with an intercept will always carry two properties. They sum to 0 and they're orthogonal to the x variable. Both come straight from the way the OLS fits the line. It pulls every last bit of straight line information out of x, so whatever's left in the residuals has nothing more to do with x. And those leftovers end up being where most of the real diagnostic work in regression happens.